Welcome, Algebra 2 students, to the homework help video. These pages right here and these numbers. Let's go ahead and jump right into this. Okay, problem number 32, the directions say, or the problem reads as follows. The designated hitter rule in Major League Baseball applies only to the American League. Let me stop and say this. If some of you do not know what the designated hitter rule is, that is okay. You do not need to know that to work the problem, okay? It's just understand this. The designated hitter rule is very, what's the word? When people debate it a lot, it's very, controversial. And so, what we have here is a matrix that give the percentages of the responses from the American League and National League fans when asked how they felt about the rule, or how they would treat the rule. From each league, there is 190 fans, so we have 190 National League fans and 190 American League fans. How many from each league said they would ban the designated hitter? How many from each league said they would expand it? Now, listen to me carefully. Let's forget this problem and come down here. I'm going to do some little math, middle school Algebra 1 type of review. If I told you that you had, I don't know, there were 200 cars in the parking lot, and 32% of those were Chevys. Okay? How would you find out the exact number of Chevys? Well, you would take 200. That's your what? Total times the percentage. Alright? And notice I'm going to use 0.32. For 32%. So you would get 0, 0, 4, 6, 64. So you took the percentage times the total to get the exact number. So out of 200 total vehicles, 64 were Chevys. Now, let's apply that to this. And by the way, I know in your notes we did adding matrices and multiplying, but the main thing we're doing in all of the word problems today is we're learning to apply our matrix knowledge, whether it be adding, subtracting, multiplying, or just answering questions like this. Now, it says from each league 190 fans were surveyed. How many from each league said they would ban the designated hitter? Okay, now, here we go. Ban the rule right here. So National League was what? 72%. American League was 24%. Got it? So I just showed you a second ago. You have a total of 200 cars. You multiply that by the percentage, and you get out the exact number of cars. Well, same thing here. We have 190 total fans, and 72% of those said they would vote against it. They would ban it. So, here we go. 190 times 0.72 is 136.8. Now, let me pause this real quick. Okay, students, I'm back. I just want to get my book open so I can check my answer. So, when you multiply 190 times 0.72, you get 136.8, which of course is going to round to 137. Now, so that's how many would ban the rule of 190 for the American League. The percentage is lower because most American League teams like to have the designated hitter rule. So 190 times 0.24, and we're going to see how many actual people wanted to ban the rule from the American League. 45.6, which rounds to 46. Okay, so from the National League, 137 people want to ban that. From the American League, 46. Next question. How many from each league said they would expand it? Okay, here we go. National League. This is expand. American League. National League says 20%. American League says 53%. So let's find out the exact amount of people, okay? We're going to take 0.20 times 190, Exactly. So 38 people from the National League would want to expand the rule. That means have the designated hitter rule also in the National League, not just the American League. 53% want it expanded. So 0.53 times 190 would give you 100.7, which would round to about 101 people. So 101 people from the American League would like to see the designated hitter rule expanded. Okay, so that's it. They just want us to read a matrix, understand what it's saying, and then answer some questions about it. Alright, number 35. The matrix shows the standard widths and lengths of 4 types of football fields. What is the difference in the area of a college football field and an arena football field? Okay, let's start with the college football field, okay? Here's your college football field right here. See it? There it is. College football field. It's 160 by 360. I think that's in feet, yes. 160 feet. 360 feet. So you guys know, how do you find the area of that? Because look, it says, what is the difference in the area of college football and arena football fields? So how do you find the area of that? Well, you guys know 160 times 360 gives us 57,600. So there's the area of the college football field. Okay, I'll put that right here with the college football field. Now, next, we're going to find the arena football area. And so it's not what I wanted to do. Let's see if that does anything. Not at all. And there we go. Okay. So the arena field, the arena football is 85 feet by 198 feet. So the area would be 16,830. Okay, so that's the area of the arena football league. So obviously, how do you find the difference? Subtract those two numbers, and you will come up with 40,770 square feet, which is the correct answer. Okay, 40,770 square feet. Alright, okay, moving on. Number 36. Now here's the opening information for 36 and 37, okay? The matrices at the right, they're down here, guys. List teacher salaries in a Pennsylvania school district from 1990 to 1994. The codes at the top classify a teacher according to the number of grad credits. The numbers to the left represent a teacher's current year of service to the district. Okay, so can I please show you what that means? Look at your matrices. They're in your book, obviously, and they're right here also. So, if you're a first-year teacher, under Class A, here's how much money you get. If you're a third-year teacher, under Class C, here's how much money you would get. These classes are, you're placed in a certain class based on how many certain type of credit hours. What did they say? Based on a number of graduate credits earned. In other words, how many credit hours do you have toward your master's degree? Okay? And so that's how they classify you. And then this over here is how many years you've taught in the district. Okay, so let's get these two matrices up here real quick, if we can. There we go. Now here's the question. The question is, suppose that in 1990 you accepted a teaching position in the school district. So 1990 right up here. Your beginning code was A, but by the end here, 1993-94, you've earned enough grad credits to be classified as a B. What would your total salary be for your 1990, you take a job, you're a first year teacher, you're in class A. The next year, you're a second year teacher, so go to the second year, you're still class A. The next year, you're now a third year teacher, still class A. And the next year, you're a fourth year teacher, but you're class B. So with a calculator, if you add up those four numbers, and I guess I could do it real quick, there's really 19,894, 21375, 24175, and 27, 175. So we have 19, carry 1, 10, 7, 24, 31, carry your 3, 11, 14, 6, carry your 1, 10, 11, 15, 22, carry your 2, 2, 4, 6, 8, 9. I'm getting 92,619. And this isn't working. Definitely didn't mean to do that. $92,619. Okay. Alright, now let's try this on the next page, okay? So, same information, same matrices. Here we go. Put them side by side this time. And here's the question. Suppose that you would reach code B by your second year of teaching. What would your total salary for 4 years be? Okay. Well, your first year, 1990. Actually, I should probably swap these. Okay, you reach code B by your second year. So your first year, you're code A. Your second year, code B. Your third year, code B. Your fourth year, code B. So, 19,894, 21,475, 24,275, and 27,175. So, carry 1, 10, 17, 24, 31, carry your 3, 11, 15, 17, 18, carry your 1, 11, 15, 22, carry your 2, 3, 5, 7, 9. I'm getting 92,819, and that is the correct answer. $92,819. Okay, so again, guys, it's nothing earth-shattering. We're just learning how to read matrices and interpret the information. Okay, all right, moving on to this number here, which is on the next page or the next section that we did. And here's the problem. You and your cousin decide to make 2 bouquets. One for your mother and one for your grandparents. The number of roses, carnations, and lilies that will be in your 2 bouquets is shown in the matrix below. So here's the matrix right here. Let's see, each rose costs $3. I better write that, pull it off to the side here. Rose, $3. Kind of pull that out of the problem so we can see it better. Carnations are going to cost $1.25. And lilies are going to cost $4. There we go. Now, your cousin agrees to share the cost of your grandparents' bouquet. Show how matrix multiplication can be used to determine your cousin's share of the cost. Okay, so first of all, they're not really asking us to to come up with exact answers here. I mean, we're going to kind of, but we're also going to use matrix multiplication. Okay, so here we go. Obviously we have a row right here, and we want to multiply it times a column. So all that we have to do is take our prices and list them like this. We'll put a cost matrix, cost, and we'll put roses here, carnations here, and lilies here. Now, the cost of roses is $3, carnations $1.25, nicely this works, guys. This is a 2 by 3. This is the 3 by 1. Your inside numbers match. You're going to be left over with a 2 by 1. So 2 rows, 1 column. 2 rows, 1 column. And look how it works. Row times column. It's perfect. You have the roses times the rose cost. Carnations times the carnations cost. Lilies times the lily cost. So we have 4 times 3 is 12. 5 times $1.25 would be $6.25. And 3 times 4 would be 12. Add those together and you get 30.25. Okay? Now, next we're going to take this row times this column. So first times first, 6 times 3. Next times next, that would be for $5. And then last times last, 3 times 4, 12. Add those up and you get $35. Now, if you'll look back at this matrix here, please look carefully, guys. This first row right here was mother's bouquet. Second row is grandma's bouquet. So, when I took mother's row times this gave me the total cost of the bouquet for mom right here. And the second row was the grandparents. So there we go. That's it. Okay. So it's not that difficult, guys. Just set up your multiplication well, and you should be fine. Or set up your matrix well, and you should be fine. Alright, next problem here reads as follows. The matrix shows the results of a survey taken by the USA Today. In the survey, people were asked why they try to eat a healthful diet. There were 8,900 men and 7,000 women. 7,000 women. Show how matrix multiplication can be used to find out how many people answered in each of the 3 categories. Well, guys, this goes back to the problem that we did before, where we have a percentage times a total. For example, let me show you what I mean. Okay. We have 0.6 women telling us they eat healthy to look better. Okay. Well, how many total women were there? 8,900. So if I put 8,900 here, and then I put 7,000 men here, do you guys not see what I have? When I multiply my matrices, I'm going to take row times column. That's spot on perfect. Look, I'm taking the percentage of the women times the total women, percentage of the men times the total men, percentage of the women times the total women, percentage of the men times the total men, percentage of the women times the total women, percentage of the men times the total times the total men. Now, I will say this. Let me read the problem again to make sure we're doing this correctly. Find out how many people answered. Okay, yes, we're looking for how many people answered in each of the 3 categories. Okay, this works perfectly, guys. So I've got a 3 by 2 times a 2 by 1. Your inside numbers match. Your outside numbers are 3 and a 1. So your answer is going to be a 3 by 1. 3 by 1. So it'll look like this. 3 rows. 1, 2, 3. 1 column. Okay? So, I'm not going to do all the work here for you, but I'm just going to say this. If I take this row times this column, I'll get an answer right here now. I've got to label my matrix correctly. This is to look better. This is to live longer. And these are the ones that don't eat healthy. That's where I'd fall right there in that category. Alright. Okay, so here we go. 0.6 times 8900. 0.4 times 7000. Now students, when you take this row here times this column here, you're going to take 0.6 times 8900 and 0.4 times 7000. Add those two numbers together and you will get 8140. Now we take our next row times our column right here, okay? 0.36 times 8900, 0.53 times 7000. Add those two together and you will get 6914. Next, multiply this row here times this column here. So 0.04 times 8900 and 0.07 times 7000, and you will get 846. So that's total. That's men and women. Men and women both. So 8,140 men and women would do it to look better. 6,914 men and women eat healthier too, live longer, and then 846 men and women don't really care to eat healthy. Okay, so again, matrix multiplication, guys, pretty simple. Alright, moving on to this next problem. Okay, I'm not sure if I paused that video or not, guys, but anyways, here we go. Alright, here's the problem. This is gonna be pretty interesting. I hope you really focus and pay attention on this, okay? This probably is not gonna be super easy, so let's give this a shot, okay? The percentage of the total 1990 world production of wheat, rice, and corn grown by the four countries that grow the most grain are given in the matrix on page 172. Now, I think it was page 171. I think they might have made a mistake there, but anyways, I went ahead and got a picture of it here. Here's the matrix they're talking about. If you'll turn back in your books to page 171, 172, around in there, you'll see this matrix. The total 1990 world production in thousands of metric tons of wheat, rice, and corn was this right here, respectively. Okay, so wheat right here, rice right here, corn right here. Show how matrix multiplication can be used to find how many metric tons of the three grains were grown in each of the four countries. Now here we go again. Look, we're dealing with percentages and totals, okay? So they're giving you the percentages right here. Here's China's percentages right here. Okay, right here. Now, this is the total amount of wheat, total amount of rice, total amount of corn. So if I take the percentages times their total, then I'll get the exact amount of tons, metric tons, that were made by that country. So I have a row here times a column over here. So I'm going to put a column matrix right here, like this, and I'm going to put 535, 842, 475, 533, and 480, comma 609. Now, I'm going to label these. This is my wheat, this is my rice, and this is my corn. So I'm taking row times column. So I'm taking wheat times the wheat total, the rice percentage times the rice total, the corn percentage times the corn total. And that's going to give me the total metric tons of all the grains that China produced. Okay, so my matrix will be over here, and it'll be going downward, and we're going to label it total grains And here we go now. So row times column. So when you take, now by the way, don't forget to move the decimal. You're going to want to use 0.166, 0.372, 0.136, 0.087. Don't forget that, okay? So you will want to move the decimals here, alright? So if you do this very carefully, let's see what we get here. For China, we're going to get 331,210.9. For India, that was this times this gave me this, alright? Now I'm going to take this row here times this column here for India, and I'm going to get 144,664.3. Okay. Now I'm going to take this row times this column, okay, and we're going to get 107,038. 107,038.3. Okay. Then lastly, the U.S. This row times this row times this column would give us a total of 272,526.7. Okay, so that's the total metric tons of grains produced by each of these countries. Okay, I hope this is making sense, guys. Alright, let's move on. Okay, students, moving on to the last problem. It's going to be an area of a triangle problem using our matrices, okay? So, here we go. The Bermuda Triangle is a large rectangular region in the Atlantic Ocean. Many ships and planes have been lost in this region. The triangle is formed by imaginary lines connecting Bermuda, Puerto Rico, and a point near Melbourne, Florida. Alright? So there it is. The Bermuda Triangle. Estimate the coordinates of these three locations on the map, and then use a determinant to estimate the number of square miles, or in other words, the area in the Bermuda Triangle. Now, each unit on the map is 47 miles, okay? Each unit is 47 miles, so here we go. Let's slide this up here for a second, and let's get to work. Now, this ordered pair right here is over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's over 18, but each of those is 47 miles. So 18 times 47. 846. So I know this ordered pair right here is over 846. And it's down how far? Well, let's see, it's even with. It's really hard to see. Let's try this. Let's get fancy here, guys. Use a vertical line, a horizontal line, and a vertical line. See if that helps us. Alright. Looks like it's going to go through that point right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I believe. So we're looking at, it's down 13. So 13 times 47 gives us 611. So negative 611 is negative because we went over and then down. Okay. Now let's find, we know this order pair right here is simply 0, 0. That's obvious. So that's easy. Now, how far over is this ordered pair right here? Well, let's see if we can't line it up like we did the other point. I think it's very close to this point right there, I believe. So Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But it's really hard to tell where that's at. I'm going to go ahead and call it 20. If I'm wrong, I'm wrong. So 20 times 47 would be 940. So we're over positive 940. And then we're going to be up. How far? Well, let's see. Right there. So 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we're up 8 lines. 8 times 47 is 376. That would be positive because we're over then up. So now that we found our 3 ordered pairs, to be honest with you, the rest of it shouldn't be too difficult to do. We're going to have some large numbers to deal with. Other than that, it should be pretty easy. Remember how to use matrices to find the area of a triangle. Remember, put your ordered pairs here first, doesn't matter. So 940, 376, doesn't matter which ordered pair goes first. 0, 0, 846, negative 611. Then we put ones, ones, and ones. Now, copy your first 2 columns over. Alright, so copy your first 2 columns over like I did right there. Alright, and now we're going to find the determinant of this matrix right here. So here we go. Oh, I'm sorry guys. One more thing. We have to put one half right here in front of the matrix. 1/2. Alright. Multiply up, you get a 0. Multiply up here, you get a 0. So the only one you get numbers on would be this right here. So negative 611 times 940 gives you a negative 574,340. But we're going to change the sign and make it positive. 5,704. 574,340. And of course the other 2 numbers were zeros and zeros. Okay, now we're going to multiply down. Well, here you get a 0. Over here you get a 0 too. But right here we have 376 times 1 times 846. So 376 times 846 gives us 318,096. And of course plus a 0 and plus a 0. Alright, let's combine these 2 numbers. 318,096 plus 574,340, and that will give us this 892,436. Alright, but then don't forget to bring down your 1/2 from right here. You've got to multiply the determinant by 1/2. Alright, and if you do that correctly, you're going to get 446,218. Alright, now that is the exact answer, but I'm surprised we got it right because I thought maybe they were going to have different points than we had because it was really hard to tell where those points lined up with. But there we go. Now it would be miles squared, and I should have put that. We're dealing with area, so miles squared 446,218. Okay, so a good problem here reviewing how to use matrices to find the area of a triangle. Okay, students,